Welcome back to day 4 of our fun week in all things electricity. Today we have an awesome project planned, and it's actually a project that's going on right now at the International Space Station and also on any submarines around the world. So if you have a dad or a friend who's serving in the military on a sub, they have this project on their sub right now. And then when they get home, you can show them this cool project and you can download all of the information you've learned, which will be really fun. We are going to get to our shout outs in a second, so if you want to shout out, make sure that you type it into the comments box. We're on both YouTube Live as well as in Zoom, so parents, if you don't watch your kids on YouTube, you can always send them over to our Zoom classroom, which has the live feed, and it also has help from Evan, so you can ask questions through the comments and all that jazz. And if you don't have our Zoom link, you can grab that over at patreon.com/rosieresearch. And like always, support starts at $1 a week, which is just a coffee a month. It's pretty easy. All right, so what we need today, just in case you are just joining us for the day and you're not sure what we need, you're gonna need some water, which is pretty easy. I know everybody has that. You're gonna need some baking soda. If you don't have baking soda, that's okay. You could also use Epsom salt is a great backup, although Epsom salt might be trickier than baking soda. A third backup, which I know you have, is table salt. There is some safety precautions with table salt, and we'll talk about that when we get there. So you'll either need baking soda or Epsom salt or table salt if you don't have the baking soda. You're going to need some aluminum foil, which is what we are going to make our leads with from our battery, because I'm going to assume that we don't have battery hats. You need a little bit of some thin cardboardy stuff. So this is just like a cereal box or the box that the cans come in. And again, you guys notice how much I'm using this. This is like major key in all of our building stuff. And then we also need like a jar or a cup, something you can see through. So you don't want to do like a plastic IKEA cup because you won't be able to see the experiment in action. So you want something that's clear. It doesn't matter if it's plastic or glass. Don't do metal because we're going to do some electricity stuff, and if you do metal, metal conducts electricity, so that could throw it off. But we want to be able to see through it. You're going to need 2 pencils, all right? And these are pencils that you're not going to care if the erasers get chopped off of, because we are going to chop those erasers off in a little bit. You're going to need a battery. I've got a few, just in case one of these guys doesn't work for me, but you need one 9-volt battery. You need a spoon to stir with. You're going to need a pencil sharpener because we need to sharpen our pencils up. And then you'll need tape and scissors. And that is all we need to make some amazing things that are happening on the International Space Station right now, which is kind of cool. Can you believe it? Like, this is all simple household stuff. And we're going to do a project that saves our astronauts and our submarine personnel. All of their lives depend on the project we're doing today, which is kind of cool. All right, so who do we have with us?
All right.
Let's see. I know Callie's here because Callie was here at like 8 a.m. pretty much. She might have been here at 8 a.m.
Hi, Callie.
Hello, Callie. It's good to see you. Georgia looks like she's joining us.
We have Ruby here.
Hi, Ruby. Oh, yay. I'm glad you're joining us today.
She's sending some good vibes to you.
Yes.
George and Henry.
Hello, George and Henry. It's awesome to see you boys here, too. I got to see George and Henry's sculpture yesterday from our squishy circuits. It was super cool. It was like black rocks holding this like really bright moon. That's what it looked like to me. I don't think that's what it actually was, but that's what it reminded me of. It was cool.
We have... Where am I? Abel.
Hi, Abel. I'm glad you're with us today. Yay, Abel's here.
And then after Abel, we got Rohan.
Hello, Rohan. What a great day to join us. I don't know if you were here yesterday, but I'm excited you're here today. This is a cool one today.
Rohan thinks that we should come up with some names for our worms.
Ooh, well, they're the Beatles, so we have John, Paul, Ringo, George.
But there's definitely more than that.
But there's more than that. You guys could all name a worm, and you could just assume that whatever worm you want it to be is the worm you're naming.
We could paint them.
We should take pictures and maybe do like a tiny Beatles.
A tiny Beatles.
A tiny Beatles outfit contest.
Hey, Ray Ray.
Hello, Ray Ray. It's good to see you today. Oh, I'm glad you're joining us.
Yeah, Miss Naomi's here.
Hello, Naomi. Naomi sent us an awesome photo of her lightning bug, and I asked some questions about her lightning bug and found out that her lightning bug that she made yesterday, it was like a sculpture of the Play-Doh with the LEDs. It was a male lightning bug, so it could do Morse code. from last week to talk to the female ladybugs, or lightning bugs. How cool is that? That was really neat. I thought that was cool.
That's amazing.
Cool project. Hopefully you guys saw it. I don't know if it was in the slideshow. If not, it will be soon.
It was, but who knows if it got to it. Sometimes we have stuff.
It's true.
We got Venetia.
Hello, Venetia. It's awesome to see you too today. Yay,
And
she had a great sculpture yesterday too. Loved her rainbow.
We've also got Mr. Good, John.
Hello, John. Oh my gosh, John. I think you're going to love today. It's going to be a fun one. I mean, it's shockingly simple and also really cool.
And I'm willing to bet Millie and Lila.
Yeah, they're here. Hello, Millie and Lila. How are you ladies today? Glad they're joining us. And I'm sure we'll have some more.
Lily has joined us.
Oh, hi, Lily.
She's back.
Yay, you're back. Awesome. Lily, I don't think we met in Zoom.
Come to Zoom.
You should come to Zoom. I would love to see you in Zoom.
Come hang out.
I know, Georgia wants you to come. We all want you to come.
And Venetia thinks that we should name one of the worms Francesca.
Ooh. Awesome name.
That's such a pretty name.
Or John.
Or John.
Or Jack.
There's lots of names that we can do. All right.
I think that's what we got.
Is that what we got? All right, so let's get started. So I mentioned that this project is literally happening right now on the International Space Station. We're going to do it today. It's actually really important to life on the space station, and it's also really important to life on a submarine. And you might be like, Dr. Erica, what is so important to life on the space station in a submarine? And I might say, oh man, it's so good to just breathe in a nice deep breath of fresh air. Wouldn't that be nice? Isn't that nice? I love it when you just fill your lungs like, oh, it feels so good, right? I mean, wait a second. How do we get air on the space station and on submarines? Because submarines kind of don't have air around them. They're kind of way underwater. Interesting. The answer is they make their air. What? They make their air. And they make it out of water. Yes, it's true. I told Isabella this morning that we were going to turn water into gas. And she was like, okay, Mom. And I was like, no, seriously, it's going to be so cool. And she was like, we kind of turned water into gas yesterday when we made noodles. And the water turned into steam. I was like, no. Back it up. Sorry. Turning water into gas, true story, she was right. Except for the gas that we do when we boil water, it's still water, right? It's still 2 hydrogens and 1 oxygen. So I totally get that she was like, not plussed. She was like, all right, Mom, great, you do that experiment. And she's right, except for we're going to turn water into gas today without it being hot. All right, so our water will not be boiling. It will not feel hot to the touch, but we're still going to turn water into gas. And in fact, we're going to turn water into gas that we could then breathe, which is cool. And we're going to do that by separating the hydrogens and the oxygen. We're going to make 2 gases. We're going to make hydrogen gas. We're going to make oxygen gas. Oxygen gas is great because we breathe it in. Not pure, but we do breathe in a mixture of it. And that's going to be fantastic. The hydrogen gas on the space station and on submarines actually gets recycled and turned back into water with what we breathe out, carbon dioxide, so that it kind of like conserves. There's this great cycle where like astronauts who go to the bathroom, we take their water. Astronauts who towel off, we take the water from the towel back. Astronauts, like any of the water that dampens on the sides of the walls, we take that back. We reclaim every little bit of water we can because we're going to make that water into oxygen gas, and you guys are going to do that today, which is super neat. I'm pretty excited. So, the first thing that we are going to do to turn water into gas. Ooh, Evan, we have a question.
Rohan is asking, how do we chop it up?
Ooh, great. We're going to chop ours up with a 9-volt battery. I know. Doesn't look like a superpower, does it? You're like, great. Seriously, are we going to use this to chop it up? We are. We're going to zip some electrons through that water, and the hydrogen and the oxygen that are in the water that are bound together in that water, they're going to be like, wait a second. There's all these electrons over here. I don't need to share with you guys. I could share with my best buddies. Like, I don't have to have oxygen in the group. It could just be me and my other hydrogen friend. And oxygen's like, oh, yes, we can have an oxygen party. So 2 hydrogens and 2 oxygens are going to get together and have a party. And they actually bind more tightly. So they're happier together. And they can do that because they have all these extra electrons that are going to be zipping through the water. And this guy is going to create the electrons zip through our water. Great question, Rohan. I'm pretty excited about it. All right, so to make it, we are going to use 2 pencils. And the first thing you're going to do is you're going to cut the erasers off of our pencils. My wood on my pencils is pretty easy, so if I put it sort of towards the back of the scissors and I rotate that pencil as I cut, I can kind of cut through it pretty nicely. It takes me a minute. Don't have to do this in one fell swoop. And once you get to a little bit, you can just snap it like that. All right, so we're going to cut both of those off. And the reason why we're going to do this is graphite is a great conductor. And we're going to use that to create 2 electrodes in our water for those electrons to zip from one to the other in the water, splitting it up. Question.
How much water do we need for this?
Well, you don't need tons of water for it. We're going to put these pencils into the water. So the pencil tips need to be submerged in water. And, I mean, that's really about it. I'm going to fill my jar about halfway up. So, if that gives you an idea. And there is actually even an easier way to do this, but I feel like it's not quite as safe. Now, I did talk about how we're going to make oxygen gas and hydrogen gas. And that was one of the reasons why we want to use baking soda instead of salt. Because salt in this process, it will split up into sodium and chlorine. And the chlorines will also find each other and become best buddies, and they will become chloride gas. Not super terrible in small amounts. It'll smell like a pool. But if you have too much or you're in enclosed space and you make too much of it, chloride gas is not something that you really necessarily want. All right, so I have my 2 pencils and I chopped off their erasers. So I just have basically 2 pencil ends. I'm going to turn these 2 pencils into 4 pencils. All right, I'm going to do that by sharpening both ends of my pencils. So I'm just going to pop it into my sharpener. And there's one pencil, and then I'll flip it over to make it into the other pencil. Oh, spat it out too soon. Back in it goes. Also, this is the best pencil sharpener ever. I love it. All right, Georgia, why don't you sharpen the ends of the other pencil too? So you can see how I actually have one pencil that made 2 pencils. I have 2 pencils. It's sharpened on both sides. And what we're going to do is we're actually going to use these pencils like a great sturdy wire, all right? Because graphite conducts electricity, and we have this lovely graphite wire that's going through our pencil. All right, so we need to expose that so that we can attach electrodes to one side of our pencil, and the other side of the pencil will end up being in the water, and that is where we'll get either the hydrogen gas or the oxygen gas forming. And as you're sharpening, here is a question to think about. So water is 2 hydrogens and 1 oxygen. And during this process, we're going to create hydrogen gas and oxygen gas. Curious if you have a guess or a hypothesis about which gas will be created more. Or will they be even? Will we have the same amount of hydrogen gas and oxygen gas produced? Or do you think one will win over the other? And if you think one will win, which one do you think will win and why? I'm curious. This is a great pencil sharpening activity because it might take a little bit for you guys to sharpen 4 ends of your pencils. Georgia's getting it going. She's working on it, just cranking away. I am pretty excited. Also, the reason why on the International Space Station they make their breathable oxygen and air this way is that they can't ship the air up. So ways that we could take air from Earth up to the space station is we could maybe compress air. But compressed air comes in these really heavy lead canisters. And those really heavy lead canisters are really heavy, which costs a lot of money to be able to get from Earth up into the space station. Oh, Georgia is leaving us.
No, I'm drinking less over here.
Okay. So we take it up to the space station. And it'd be like too much money. You don't get enough air for how much it costs. We do have a backup system because this process of electrolysis, which is what we're doing, splitting water into hydrogen and oxygen gas, doesn't fully create enough oxygen for the 3 astronauts that are on board. And there is a backup system where we send up, I forget exactly what it is, but like I think it's like powdered iron and powdered maybe magnesium sulfate. And we can burn the two together to create oxygen, which is sort of what fills the gap. But even that is really expensive to get up there. And we obviously want to be able to have a system that makes oxygen on board as we go. You don't want to have to like ship up air every single time, because what happens if, like yesterday, a shipment gets delayed due to the weather, right? We were supposed to launch up to the space station yesterday, and we couldn't because of the weather. So what would happen then? Like, our astronauts cannot hold their breath for 2 days and wait for a new air shipment. So we do need to make sure that we're very reliant and self-reliant while we're up there, or even on a submarine, right? You can't always wait for a shipment to come in. Speaking of which, tomorrow is the new launch. Tomorrow? Wait, no, tomorrow's Friday. Saturday is the new launch date for the crewed launch up to the space station, so you should definitely watch if you can. Yes?
Venetia thinks that hydrogen will be more hydrogen gas.
Interesting. Why do you think that, Venetia?
We'll have to wait. Just 10
Yeah.
seconds.
Oh, yes. So, Venetia, I'm curious. We'll wait because I know we have a delay. And I hope you guys are still sharpening your pencils. We're going to get sharpened on both sides. That's very important for us. George is working hard on her sharpening, which is awesome. And once we have them sharpened, we'll get on to making our wires. In fact, we could probably start right now. So we're going to take our foil. If you don't have a 9-volt battery cap, just like we did yesterday, we're going to do the same thing. So we're going to take off 2 pieces of foil. We're going to keep them this nice length. Thank you, Georgia. And what we'll do is we're going to fold them like super long hot dogs a few times to give our foil wires lots of strength. So if you were with us yesterday, we did this yesterday when we made squishy circuits to attach our 9-volt battery into that Play-Doh. All right, so you're going to fold it like a hot dog, and then you'll fold it like a hot dog, like this. And then you'll fold it like a hot dog, like this. And I think we could fold it one more time. And this just, every time we fold it, gives it a little bit of extra strength so it doesn't rip as easily. Because the most frustrating thing is when you get like these wires together and you think you have it all done and then a wire rips. And if a wire rips, that highway for these electrons to go on no longer exists and you've totally broken your circuit. There's no way to like quickly and easily necessarily fix it. Yeah.
Can we reuse the battery from yesterday?
You can totally reuse the battery from yesterday. Absolutely.
And that way you
In fact, you might already have your little 9-volt battery hat all hooked up. Although your battery wouldn't work if overnight your 2 foil pieces on the battery from yesterday were touching each other, because you would have lost all of the current. Your electrons, all the electrons you had as runners would be gone by now. But as long as your 2 pieces of foil didn't touch overnight, you would be totally good to go, and you could just skip this part right here. I am just going to fold it one more time after this. And I'll have 2 of my wires. We're going to make the battery hat like we did in the second part yesterday, because I think that was a lot easier. Sometimes when I do things on my own, I'm like, oh, that's not too bad. But then when I see that people might be having issues with it, I'm like, there's actually an easier way to do this. That's what we do as engineers and scientists.
How much water again?
About like half to 3/4 of whatever your jar is or your cup is. It's not a precise measurement. Does not need to be. All right, so we do have these 2 pieces. If it's already attached to your battery, you're gonna skip this part for now. And if it's not, if you're making it with us, what we're gonna do next is we're actually gonna roll this onto it. We need to make sure that the foil touches the pencil. So what I'm gonna do is, instead of holding the foil and the pencil so that like they're sort of overlapping each other, I'm gonna hold it so that they create this long extension. Ooh, I don't like this part, so I'm just gonna cut that part off. So that creates this long extension, and I'm going to then pinch it onto the pencil, and I'm going to wrap it around the pencil. All right, so I'm just gonna wrap it around my pencil until I get up to the graphite, and that's really important that my foil touches the graphite. So you're gonna wanna really pinch it really good right there. important part. All right, if we don't touch that graphite, we won't end up working out well. All right, so I've just sort of made like a little hat for this.
So do you put
And
it
I'm
on
going to
the
pinch
tip?
it around. Yep, you're going to put a hat just like that on the tip. You're going to twist it around, and you can secure that in place with a little bit of masking tape, duct tape, scotch tape, whatever kind of strong, sturdy tape you have. I didn't mention copper tape because I don't think copper tape is very strong or sturdy. All right, so I'm going to tape this piece on. And it's okay if you tape over this because this is the part that's already touching that graphite, although I think I might have just broken my lead in there.
Yeah.
I guess we'll find out when we do the experiment.
Yeah.
Beautiful. Georgia's got hers going. So we are going to tape hers on. So it's okay if it pops out. That's why we're going to tape it on for you guys. And then, oops, let's see, grab it from the floor. So we're going to stick her little pencil guy in. I'm going to pinch it on there, and then we're just going to tape it on so it doesn't keep falling off, because that would be really frustrating if it just keeps falling off all the time. All right, so we're going to tape it on. So I have 2 pencils, and the top pieces are now having foil connected to their lead, and I just taped it in place so it's nice and sturdy. And then I have the other part of my pencils that are completely free. So it's not one pencil with 2 pieces of foil. Each pencil has 1 piece of foil. So it has 1 tip covered in foil and 1 tip that's free. And they look identical. My pencils are the same look. All right, so we're gonna put that aside for a moment, and we are gonna make a lid for our container because we want to keep these pencils just ever so slightly apart when they are hanging out in the water producing that hydrogen gas and that oxygen gas. So what I'm gonna do for that is I'm gonna just cut a little square out from my cardboard. And whatever cup you have, you can just take it, you can flip it over, and you could even use your pencil and trace around it. Yes, we have a question, or a guess maybe.
What are we going to do with the gas?
Ooh, also a great question. Our gas is just going to go off into the world. Things you could do if you happen to have something like a test tube at home, which is why I did not include that in here, because I think test tubes are a little tricky, is that you could actually put test tubes above these pencils and try to collect the gas if you wanted to. Yep, you're going to cut it out. And then you can kind of do like whatever, I guess, with the gas. Some people try to burn it, but I feel like with kids, that's a little tricky. The cool thing is if you do capture the hydrogen gas and with a parent very carefully, you burn it, it will burn blue. But that's kind of, I mean, right now we're just watching it. On the space station, we take the gas. So the hydrogen gas goes off into another system where we can recycle that hydrogen gas back into water, and the oxygen gets mixed into the air for the astronauts to breathe. Same thing on submarines. So you take the hydrogen gas and it gets mixed back into water, and the oxygen gas comes on in and it lets us breathe. So normally when we use this, we actually use the gases to breathe. But today is just sort of a fun project. So you could collect the gases. If you collect the gases, you could test if one of them makes more gas than the other. Venetia has the guess that hydrogen will make more gas than oxygen. But that would be a way, if you happen to have test tubes, you could actually test it. You could collect the gas and see, does one collect more gas than the other? And if so, which one? Ooh, but then how would you know? Because gases are clear. Oh, so tricky. We can talk about that. All right, so we traced around the lip of whatever cup that you're using. And then we're going to cut out that circle, which is what Georgia is doing for us right now. And what we're going to do after we cut out that circle is we're going to poke our pencils through the lid kind of close together. So if I look at my lid, I have like a center point like that. I'm actually going to sort of put my pencils kind of in the center, but a little bit off center so that they can be close to each other, but not like right on top of each other. So I'm just going to take my pencil and I'm going to poke it through.
Looks like we have Emerson here.
Oh, hi, Emerson. Oh, my pencil lead is maybe not strong enough for this.
Mine.
Hang on, I'm going to take a pen instead. All right, so I'm going to take a pen and poke it through where I was going to put my pencil at. And then once I get through, this is like stronger than last time I had to poke holes. There we go. All right, so now I've got a hole started. I can start to poke my pencil through. I'm just going to twist it as I poke it through until it can stand up just like that.
Okay.
So I made a hole through it, and I'm going to start a dot for Georgia.
No, I want to do it.
And then, let me start it for you. And then you can poke your pencil through, please.
No.
Please.
I want to do it.
Okay, Georgia is going to do it. All right, so then we're going to poke the second one through. And hopefully Georgia puts it in the right place. We'll find out. You want them kind of close together so that we can put them in the water and they will be close together and create the different hydrogen and oxygen gases for us. And I had a lot of trouble getting the pencil through, so I'm a little bit worried about her getting the pencil through.
Which way?
It doesn't matter which way right now.
What time are they launching on Saturday?
That is a fantastic question. I don't know the answer to that. Maybe Evan could check out online. I know they tried to launch yesterday at 1:33, and we got past the 45-minute window, I believe. They looked like they were ready to go, and then like very close towards the end, like right before they sort of said, hey, you know what? The weather's not good. Everything else in the system's checked out, which is great. And then the astronauts had to sit on the capsule for like another 40 minutes or an hour as all the fuel got offloaded. We were so close to launch that everything was on board, ready to go, all the systems checked out, and then we said, oh, you know what? The weather's not quite as good as what we'd like. And this is a really important thing, right? We don't want to just go and hope that it works because we have 2 people on board, and these launches are very expensive. They have a lot of things that go into them. If we accidentally have a problem and something breaks, it's going to take a long time to fix. It's better to wait until your conditions are well within your window.
I did it without the pen.
All right, so Georgia's got a second hole. And so you can notice that my 2 pencils I can put in here and they'll be like nicely apart. They're not like wobbly. The holes aren't so big that they're wobbly. And what we'll end up doing is we're going to put this into our jar. All right, and you want to be able to push your pencils far enough down. I think we'll probably push ours down about this far so that we can tape it or we can see it into the water. So I need to, people who are asking how much water we need, I need to fill my jar up at least like sort of to the yellow line of my pencils. All right. Okay, so I'm going to take my pencils out for right now, actually. And I am going to put some tape and tape it onto the lid. So, oh wait, before we do that, we should probably put our water in, shouldn't we? We're going to add some water into our jar. All right, and Georgie, you can add the baking soda in and mix it up for me in just a minute. So I'm going to add this water into the jar. And then we're going to add in a spoonful of baking soda. So I'm just going to, you don't have to have a ton. Spoonful will work great. And Georgia's going to add that in and mix it up for me. And what the baking soda will do is it helps the water conduct electricity.
Mama, look at the big bubbles coming
So
out.
when we add when we have distilled water is literally just things that are H2O, nothing else. Tap water has extra things in it. It has like fluoride in it. It might have some other things from the pipes that are in it. It has, rainwater is not distilled. It has all sorts of minerals in it, and those help conduct electricity. But this is just going to help it conduct a little bit more. I want you to mix it. And it's also another way to help it conduct is either using salt or like an Epsom salt type of a thing, and that will all help. This just helps those electrons have a better pathway to run across from one side to the other and create the hydrogen and the oxygen gas.
Can I tell you something?
Georgia's noticing something. What are you noticing, Georgia?
When I put it in, it floated to the bottom, and then some bubbles came out.
Ooh, some air bubbles that were on it, maybe. All right, so ours is pretty much all mixed in. The amount that you put in, you don't need to put in gobs of it, and you don't need to put in a pinch of it. So just put in like a spoonful, and you'll be totally fine. It doesn't have to be precisely measured. All right, so once we've mixed that in, we're going to tape on our lid. All right, so yeah, I'll take that spoon out. Thanks, Georgia. And we're going to tape our lid on to our little canister. Georgia, if you'd like to, you could add a few more pieces of tape to really tape that lid on to us.
Can I put it in after?
All right.
Can I put it in after?
You put it in after. Yes, but we're not going to put it in quite right away. All right, so now we are going to attach our foil ends to the batteries. So if you had your battery already done, you're already connected, so you're good to go. We are going to take our battery, and we found yesterday it's easier if we just attach this one straight here and that one straight there. I'm going to like roll it up a little bit to make sure it gets nice and good contact. I try to smush it into this hole of the battery, and we'll tape it in place so that it's like more secure. All right, our goal is always to be super secure with these things. Ooh, that's a great spot to hold that tape. So I'm going to just tape this on. I have a little bit extra that I can pop in here, smush it all in, let's see, into that hole so it just gets hopefully a little bit better contact. It is a 9-volt battery, and we're going to tape straight over the top, just like that. We do want to make sure that the 2 pieces of foil don't touch anymore, because 9 volts going through foil will create really hot foil really quickly. All right. And I'm going to tape this down just to be a little bit more secure. And then we're going to do the same thing on the other side. So I'm going to sort of make this into like a little crunchy ball. Georgia would like to try. You're going to put that crunchy ball right inside the big hole.
What if it doesn't fit?
That's it. You're just going to smush it in with your finger.
That?
Yep, just like that. And then we're just going to tape over the top.
Like a long hole.
Yeah.
It was like this.
All right, and you can press down after you've taped on the tops of those holes pretty well. And then we're going to tape that piece down too.
What is the touching?
We don't want the foil to touch because that will be a free highway for our electrons. But what you can do, and I don't know if we'll be able to get this on video, is now I have 9 volts, and the 9 volts really want to go from one pencil to the other. All right? We talked about how air is a great insulator, but what happens on stormy nights, Georgia? Do we see electricity in the air on stormy nights?
No.
We don't? We hear big booms.
Does that mean electricity?
And the sky lights up?
Yeah.
What is that?
Electricity, I guess.
It's electricity. Lightning, yeah. So air, the insulation of air breaks down when we have lightning. And we should be able, I'm not sure if this battery is going to be strong enough after yesterday, we should be able to create lightning between our 2 pencil tips. You have to get them very close together, within a few millimeters. But you should, oh, mine are not sparking. Interesting. That actually might be a cue that you have a little bit of a problem with your circuit or your battery. I might have grabbed the dead battery. We'll find out. But I also remember mentioned that I might have broken the lead in here when I did this. So I'm going to just push on these guys and double check. Not getting anything. All right, you might have gotten something. You should have seen some lightning. And if you didn't, we'll try it in the water real fast just to see. And if not, we can always try. I have that break that I think I heard, which could be a big problem. So I'm thinking maybe I resharpened my pencil and maybe I switched batteries. But let's see if I can make some gas by putting my pencils into the water. So I'm just going to pop them through these holes like this. Oh, no, it's working. So my battery is not strong enough to produce the lightning. It's not as strong as a typical 9-volt battery, but that's okay. If your battery was a little bit more charged up than ours, then you probably would have seen it. But I'm going to tape my battery to the back of this, just so that it's sort of stable. We're just going to tape that guy up there. And then, Georgia, what do you see on our pencil tips? Do you see anything on our pencil tips? What's going on down there?
Bubbles are coming to us.
There's bubbles! There are bubbles coming off the tips of our pencils. From the moment I put it in the water, those electrons started screaming through that water, and the water molecules were like, the hydrogens were like, ooh, look, extra electrons. And they were like, oh, I'll see you later, oxygen. And the 2 hydrogen molecules got to find each other. The 2 oxygen molecules got to find each other. And they are creating hydrogen gas and oxygen gas. So all the hydrogen gas is on one pencil, and all the oxygen gas is on the other pencil. And you might notice there is one pencil that is indeed creating more bubbles than the other pencil. And Venetia is correct. That is the pencil that is creating hydrogen gas. And the reason for that is there are 2 hydrogen molecules and 1 oxygen molecule in water. So if I took 2 waters together, I'd have 4 hydrogens and 2 oxygens, and that would give me 1 piece of oxygen gas, O2, because I need 2 oxygens for oxygen gas. I need 2 hydrogens for hydrogen gas, and I would get 2 of those. So I get 2 sort of molecules of hydrogen gas and only 1 of the oxygen gas, which is why I get twice as much hydrogen gas coming off of my pencils, and it bubbles more. Ours are not bubbling as much as I would like, so I'm going to add a new battery. We'll see if that fixes it for us. And the reason why I've been shying away from these, we have rechargeable 9 volts, but I'm not sure if they're actually charged
now
up.
it's coming off. Look.
Yeah, so the moment that I stop putting the electricity through there, I shouldn't see any more new bubbles forming. I know we have a few batteries. I cannot remember which ones are charged and not charged, and which ones were used and not used. That's okay. No big deal. We're going to try this one. I think these guys might be charged. All right, so let's see if we can make some extra bubbles here. And again, the way that we do that is we just tape it to this piece. We're going to smush it in nice and hard, and we'll tape it on into there. And then I'm going to take this guy over here. He's gone to the garage and gotten us some brand new ones that should be good. All right, let's see. Ooh, I'm noticing this one did not do anything. I'm guessing this is a rechargeable one, so I'm guessing I've used it.
I got a question for you.
Yes.
If we have a battery hat, do we just tape the wire ends to the pencil tip with masking tape or copper tape?
I get why, Mama.
I wouldn't use copper tape. Masking tape is a lot stronger. Like copper tape, I don't know, it doesn't stick as well. It rips easier. So I think that if you have masking tape, I would use masking tape to stick it.
And they're both different, please.
They are. George was noticing that on the battery, there are 2 different terminals, and that's to help us always know which one's the positive and the negative. The negative terminal is the bigger terminal, and the positive terminal is the smaller terminal. All right, let's see. We're going to attach this to a, in theory, brand new battery. But I am excited that we did get some good. We need to charge our 9 volts today, because tomorrow we're actually doing circuit drawings with a 9 volt battery that doesn't use copper tape. Which is kind of cool. Yeah. All right, let's see if this one is doing it for us. Yep. So I just taped this one in, and all of a sudden I got my bubbles going again. I'm not sure if we can get like a close-up on our bubbles. But it is bubbling. It's bubbling whether or not they're close or far from each other, but you know, the closer you go, the faster you're gonna create some bubbles. I think we're gonna try to get this guy so you guys can have a close-up of our bubbles. Thanks to our amazing studio department, aka Evan. Now, if you are enjoying this project, there are some other projects you can do with this apparatus. So you could check different solutions. You could maybe even take like a video of the gas that's being produced with baking soda in the water, and then you could dump your water and you could try new water with a little bit of salt, and you could see, does that work better or worse? You could add an acid like a lemon juice or vinegar. You could try different types of salts. You could try all different things and see if, does that help this create more bubbles quicker, or does it take longer? What about regular tap water? Does that create bubbles faster or slower? It will always still create bubbles, but how quickly it produces bubbles will change. But you can see on the pencil towards me over here, we have a lot of bubbles going on. And questions.
Ray Ray's asking, why water's sign thing is H2O is because it takes 2 hydrogens and 1 oxygen to make water? Question mark.
Yes, so that is why. She's asking why is it 2 hydrogen? Yes.
Why is it like that?
Okay, so oxygen it's all about how many electrons these guys carry around with them. So all of the elements that we have, they are made up of like a really dense center, and then sort of what we call a cloud, and that cloud is our electron cloud. And the center changes. So like for hydrogen, it's just like 1 proton hanging out. For oxygen, you have like 6 protons and 6 neutrons, and they're hanging out together, really consolidated. And that number of protons that are in there also tells you how many electrons are out whizzing around in the cloud. And there are things called like shells. Your clouds can like make these cool shells, and they always want to create a shell if they can. It just so happens you need 8 electrons to make a shell for oxygen. So oxygen really wants 2 more electrons to feel whole. It doesn't feel whole with its 6 buzzing around in its cloud. It wants to have 8. Hydrogen wants to have 2 in its shell. It really wants to have 2, but it doesn't have 2, it only has 1. And so what happens is that when the hydrogen and the oxygen see each other, the hydrogen's like, ooh, you know what, maybe we could share. Could I kind of share one of your electrons and also share my electrons? So like I get 2 and you get 7, and oxygen's kind of like, I don't know. But then hydrogen's like, ooh, but I'll bring my friend. My friend will come and my friend will share its electron with you if you share another one with it. And so it's like, well, if you and your friend come and we're sharing, I'll have like 8 kind of in my shell, and you guys will both have kind of 2 in your shell. But we have to be really close together. We have to be snugly. And they're like, all right, that's cool. And that's how you get the 2 hydrogens, because oxygen really wanted 2 electrons to be with it, which is cool. I'm noticing really quickly that I've already burned through. Oh, no, I'm still going. Look at all those bubbles on there, Georgia. There's a lot coming off. I know.
Naomi's wondering, can the pencil tips touch inside the water?
You could totally try. So you can also see what happens the closer you bring them. I'm not sure geometrically if I can really get my pencils to touch inside. Let me see. Let's give it a try, Naomi. Because what is science without just trying something interesting? Let's see. I'm noticing that like if I go really far apart, it slows the bubbles down. I'm not sure. Can we see our bubbles right now? It slows the bubbles down, but as I go closer, it speeds up the process really fast. I'm not able to get my pencils to touch each other. I can just get them like within a few millimeters of each other. But it is cool to see that if you sort of come way out here, it dramatically slows it down. Like I'm really, really close. It doesn't. I mean, you need to produce the gases. We do need to go through the water. We need the electrons zipping through the water for the hydrogen ions, for the hydrogen and the oxygen to break apart and grab a hold to create the hydrogen gas. We do need that to happen. So I think if we just touch it, we might not be seeing it as much. I really kind of want to do this. I'm thinking maybe we're gonna break our apparatus just so we can see Naomi's question. I love doing this though. Look at that. You can see all those bubbles coming off. Oh, did I? No, I just knocked wood. All right, hang on. I'm gonna put this down for a second. I'm gonna pull. Really, you know what I'll do? I'm gonna take my lid off, Naomi, and I'm gonna just go straight in. I think from the side, we're gonna rip the lid with some scissors. By rip the lid, I mean I'm gonna cut my lid so we can check out Naomi's question. All right, there we go. Now I should be able to move it any which way. So I'm gonna put this guy back in. I'll hold it up for you guys. And let's see. Here we go. We're gonna get eyes. Can we do it? I might need to put this down and use 2 hands.
Making steam.
It's not making steam. Ooh, I'm so glad Georgia said that. It is not actually making steam because steam is water. It's an H2O combination.
I noticed that the water makes it look bigger.
Okay, there we go. We're touching.
The water makes it look bigger.
All right, so when I touch, it seems like we reduce. Oh yeah, when we touch, it just goes straight through the pencils. And our bubbles reduce. Are you able to see our bubbles, Evan? Am I too low for you?
Mama, is it air that's coming out?
It's oxygen and hydrogen. So we split the water into 2 hydrogens and 1 oxygen, and then they regrouped into gases. Can we put it on this maybe?
Mama,
We'll make a makeshift stand really quickly.
It looks bigger when it's like
And
in the water.
so as I go kind of close, you can see, hopefully, that there's like lots of bubbles getting produced. But when I touch them, it really quickly slows down, and that's because it's now just going through the pencils, not through the water. So we don't have, but once I just like even slightly separate them, whoo, look at all those bubbles going. Then I touch them, and you can see them just come to a halt. Open them. Naomi, I'm so glad you asked that question because we really do need those electrons flying through the water to break the water molecules apart into the hydrogen and the oxygen gases. If they just go tip to tip, then we have a circuit that goes straight through my pencils, and we're not really creating a gas. I'm creating a little bit, but that's because the whole tips of my pencils aren't actually going. But look at that, when I just separate ever so slightly, you get a lot of gas getting produced really, really fast, which is cool. Oh, that was such a great question. And then, of course, that goes to show that, like, over here we get, you know, a little bit. As we get closer, it gets more and more and more. But if we get too close and we touch, it pretty much stops if we touch in the right way. There we go. Which is really cool. Great question, Naomi. All right, and this is a really fun project. You guys can dump this water, try it with salt, try it with vinegar, try it with just tap water, and see how long does it take for those bubbles to form, how quickly are they forming, and, you know, sort of lets you see what's going on, which is super cool. And this pencil that's on your guys is on this side. I don't know if that's your right or your left. I think that's your left. That is the one that I have hydrogen gas coming off, because just like Venetia thought, I'm creating more hydrogen gas than I am creating oxygen gas, and there's more bubbles on that pencil. So that is the gas that if I collected it, it would burn blue, whereas the other one would burn orange, just like a normal flame. Kind of like what we see. Awesome. That was fun. Look at that. Did you think that you would do a project today that is happening literally right now on the International Space Station? That's pretty cool. I'm kind of excited about that. We are going to check out your guys' projects over in the Zoom classroom. If you have other questions, you can always ask us over in Zoom, and you can show me, you can tell me what you're thinking is happening, or if you're already doing the other experiments with different kinds of liquids. I'm so excited to check in with you and see what you're finding over there. And then I hope that you guys will join us tomorrow as we make an LED light up with just a drawing, a 9-volt battery, and an LED. Now, you might have an idea about how that's happening now that we've done this project, but I think it's still pretty cool nonetheless. We will not be using our traditional copper tape highway for those electrons to zip through into that LED and light it up. So that'll be fun. And we will be live tomorrow at 11:30 doing that project with you guys. All you need is your 9-volt battery, some paper, a nice sharp pencil, and an LED. Oh, and some Scotch tape. That's it. Pretty cool. All right, friends, I will see you over in Zoom as we have lunch together. And for our friends on YouTube who won't be coming, I'll say goodbye for today. And I hope that I get to see your guys' projects. You can always email your pictures to drerica@rosieresearch.com, and we can put them into our pre-show so you can show all of your amazing work to everybody else who's out there watching us. Have a great afternoon. Bye.